guidance down the correct descent angle to the touchdown point of the runway. Vertically directed radio fan markers along the localizer beam enable the pilot on final approach to check his position at definite distances from the touchdown point. A bad weather approach is controlled by the pilot's reference to many different aircraft instruments. The key instrument in an ILS approach is the ILS indicator located in the aircraft's instrument flight panel. It is a special type of meter operated by the output from the aircraft's glide path and localizer receivers. The localizer and glide path beams intersect to form a cross. As the signals are received in the aircraft, they are seen by the pilot as movements of two crossed needles in the ILS indicator. The marker signals are seen as flashing indicator lights on the instrument panel and are heard in the pilot's headphones as code signals. Now we have seen the main elements of the ILS used by the pilot on his approach to land. Let's take a closer look at the ILS localizer. The building housing the localizer beam transmitters and antennas is located on an extended center line of the instrument landing runway opposite the approach end of the runway. This unit is always placed in a position where it will constitute a minimum hazard to aircraft using the instrument runway. The localizer beam transmitters are designed to provide an on-course signal directly down the center of the runway, extending to a minimum distance of 25 miles. The localizer antennas radiate two lobes of directed radio energy of equal signal strength. The axes of these lobes lie almost parallel to each other, so that the inner portions of the lobes overlap. It is this overlap that provides the on-course localizer beam. The localizer beam is very sharp and well defined along the entire length of the two lobes. The two lobes are modulated at different frequencies. Looking toward the localizer transmitter from the approach direction, the right side or lobe is modulated at 150 cycles per second, and the left side is modulated at 90 cycles per second. The right-hand lobe is known as the blue sector, and the left-hand lobe as the yellow sector. In the aircraft, the blue and yellow sectors are usually identified as yellow and blue areas on the ILS indicator. On the ILS indicator, the blue area is on the left side, and the yellow area is on the right side. The vertical needle actuated by the aircraft's localizer receivers shows by deflection from the center the color of the sector in which the aircraft is flying, so that the pilot can tell if the aircraft is to the right or left of the center line of the instrument landing runway. The aircraft is on course when the vertical needle is centered. Flying inbound, the needle always indicates the direction to the localizer beam. If the inbound area, the aircraft must always be turned in the direction of the needle deflection. So a left turn toward the needle will bring the aircraft back to the localizer beam and the needle to center. If the inbound aircraft crosses the beam into the yellow sector, the needle will be deflected to the right into the yellow area of the indicator. A right turn toward the needle will bring the aircraft back on the beam and center the needle. The localizer beam spreads at a 5-degree angle from the transmitter antennas and is aligned so that the spread will be 2 1/2 degrees on either side of the instrument runway center line. At the point of touchdown on the runway, the beam is approximately 70 feet wide. At 10 miles out, where the pilot usually maneuvers his aircraft to align it with the beam on the inbound heading, the beam is approximately 5,000 feet wide. The indicator's vertical needle is very sensitive and will show a full-scale deflection if the aircraft is 2 1/2 degrees to either side of the center of the localizer beam. The face of the indicator is marked to show the center, and a horizontal scale indicates fractions of the 5-degree spread of the beam. This high sensitivity makes possible the use of the ILS indicator for accurate runway localization. If the needle is no farther off center than 1/4 of the scale, the aircraft will be in position as it approaches the threshold to land on the runway. Now let's look at the ILS glide path. The ultra-high frequency glide path transmitters are housed in a building approximately 1,000 feet from the approach end and 400 feet to the right of the center line of the instrument runway. The beam projected by the glide path transmitters is essentially the same as the localizer beam would be if it were tilted on its side. The upper lobe of the glide path is modulated at 90 cycles per second and the lower lobe at 150 cycles per second. The glide path is slanted up at an angle of approximately 2 1/2 degrees above the horizon, unless obstructions or other hazards make a somewhat steeper angle necessary. In no case is the angle of the glide path less than 2 degrees or more than 4 degrees. The glide path beam spreads at an angle of less than 1 1/2 degrees from the transmitter. The glide path is much sharper than the localizer beam. For all practical purposes, it should be considered as a single line at the runway threshold. At the point where an aircraft will usually intercept the glide path, it is approximately 450 feet thick. The glide path receivers in the aircraft actuate the horizontal needle of the ILS indicator. This horizontal needle indicates by deflection up or down from center the position of the aircraft with respect to the glide path. When the aircraft is directly on the glide path, the needle is centered horizontally across the middle of the dial. When the inbound aircraft is above the glide path, the needle will be deflected downward. When it is below the glide path, the needle will be deflected upward. As in the case of the localizer needle, the inbound aircraft must be flown in the direction of the needle deflection to bring it back to the glide path. It is necessary that the aircraft be aligned accurately on the glide path at some distance from the airdrome, so that only very minor corrections will be needed as the aircraft nears the runway. In the ILS indicator, the horizontal glide path needle moves from full-scale fly up to full-scale fly down as the aircraft climbs or descends through the less than 1 1/2 degree thickness of the glide path. Marks on a vertical scale on the face of the indicator divide the movement of the needle into fractions of a degree, indicating accurately the aircraft's position above, below, or on the glide path. The glide path needle should be kept within the limits of full-scale fly down and half-scale fly up indications during the approach. If a pilot making an ILS approach maneuvers his aircraft in such a way that the two needles of the ILS indicator are kept centered, the aircraft will be flying along the intersection of the localizer and glide path beams, and it will be aligned in a proper position to land when visual contact is made. The radio markers used with the ILS are low-powered radio beams of approximately 2 watts output, operating on the fan marker frequency of 75 megacycles and radiating a vertical fan-shaped field pattern. There are generally three of them: an outer marker, a middle marker, and an inner marker. The outer marker provides the first definite checkpoint at which a pilot on final approach can verify the altitude of his aircraft and its distance from the runway. It is located approximately 4½ miles from the approach end of the instrument runway and is aligned as closely as possible with the extended center line of the runway. The outer marker is modulated at 400 cycles per second and keyed to emit low-toned dashes continuously at the rate of 2 per second. The middle marker is located where it will indicate in low visibility the imminence of the runway approach lights. It is approximately 3,500 feet from the approach end of the runway on a line between the end of the runway and the outer marker. This marker is modulated at 1,300 cycles per second and keyed to emit medium-toned alternate dots and dashes. The inner marker, when installed, is located where it will indicate in low visibility the imminence of the runway threshold. The antenna is approximately 250 feet from the approach end of the instrument runway, with the transmitter housing unit approximately 200 feet left of the center line of the runway to avoid its being a hazard. The inner marker is modulated at 3,000 cycles per second and emits a high-toned stream of dots continuously at the rate of 6 dots per second. The marker signals, as they are received in the aircraft, show as 3 lights: purple, amber, and white. These lights are mounted on the aircraft's instrument flight panel. If the marker receiver is connected to the earphone circuit, all marker signals may also be heard by the pilot in his headphones. Now we have seen how the main parts of the ILS operate: the localizer, the glide path, and the markers. Since even a slight malfunctioning of the ILS equipment in bad weather could place the pilot in a critical position, it is necessary that some means be provided for ground personnel to keep a close check on the operation of the entire system. Lines are run from receivers at the localizer and glide path transmitters and from receivers at each marker transmitter to a monitor panel within easy reach of the approach controllers. Lights, buzzer signals, and bells give warning when anything goes wrong and provide controllers with a constant visual and oral check on the operation of the system. The pilot, too, should have a constant check on the ILS receiving equipment in the aircraft. Many ILS indicators are equipped with small red flag alarms bearing the word "off" to indicate when the aircraft receiving equipment is out of order. When the equipment is on and working properly, the flags swing out of sight beyond the rim of the dial at the right-hand side and at the bottom of the indicator. If either the glide path or the localizer flag alarm is showing, the pilot will disregard the indications of the associated needle. At many aerodromes where ILS is available, there are 2 localizer beams, a front beam and a back beam. If the back beam is lined up with the front beam, it may be used for orientation when the pilot is changing over from other navigational aids to the ILS or during missed approach procedures. Let's follow a training flight at Friendship International. The aircraft is approaching the Friendship range station on a procedure that will take the aircraft over the aerodrome on the low-frequency range and outbound on the ILS localizer. The pilot switches on the ILS receivers about 10 minutes before they will be needed for the ILS approach to allow them to warm up and become stabilized. He checks the operation of the equipment by watching for the flag alarms in the ILS indicator. The receivers are remotely controlled from a small panel within easy reach of the pilot. The panel contains an on and off switch, a volume control, and a channel selector switch. The glide path and localizer transmitting frequencies are paired so that every localizer frequency has a corresponding glide path frequency. When the pilot selects the proper localizer frequency, the channel selector switch is designed to switch the glide path receiver to its corresponding frequency automatically. The aircraft is now flying outbound in the yellow sector of the front beam of the localizer. When the aircraft is turned around and is outbound on the front beam of the localizer, the needle points away from the beam because the indicator has also been turned around. The vertical needle, as always, indicates the sector in which the aircraft is flying, and the needle is still centered when the aircraft is on the beam. Now, however, the aircraft must be turned in the direction opposite to that of the needle deflection to bring the aircraft toward the beam and the needle to center. It is important when flying the ILS to visualize the position of the blue and yellow sectors on the ground with respect to the localizer beam. Some pilots orientate themselves with respect to color alone. They think in terms of flying toward the opposite color to the one they are in, regardless of whether they are flying inbound or outbound. The end result is the same as flying toward or away from the needle. The training flight is outbound, and the needle is deflected to the right into the yellow area of the indicator, so the aircraft must be turned away from the needle to the left to bring it toward the localizer beam. Once the aircraft is on the localizer beam, a definite gyro heading should be maintained a moment or two to see if the needle moves to one side or the other. This gives the pilot an indication of how much wind drift there is, if any, and consequently the amount of correction necessary to compensate for wind drift during the remainder of the approach. While the aircraft is outbound, the pilot is able to check the ILS markers to make certain their signals are being received properly for the final approach. The pilot should now go through the landing checklist and slow the aircraft to approach speed. This will allow him to give his undivided attention to tracking the localizer and glide path on his final approach. When the pilot sees the purple marker light flashing on the instrument panel and hears the low-tone signal in his headphones, he knows the outer marker has been reached. He carefully notes the time and flies outbound for 2 minutes from the outer marker before starting a procedure turn to the left to turn the aircraft around for the final approach. He will also notice some movement of the glide path indicator needle. He should disregard this, since when the aircraft is outbound, its glide path receiving antenna is in the shadow of the aircraft itself. It does not receive a true glide path signal until the aircraft is turned to the inbound heading. The last portion of the procedure turn may be widened or tightened to compensate for any wind drift and put the aircraft directly on the inbound heading. At this point, the aircraft will usually be in level flight and underneath the glide path. The pilot maintains level flight so that he will intercept the glide path at some distance outside the outer marker. This will give him plenty of time to establish his rate of descent before the outer marker is reached. As the aircraft comes into the glide path beam, the horizontal glide path needle will start moving slowly downward until it reaches the center of the dial. At this point, power is reduced to keep the needle centered. Remember, the horizontal needle always indicates the direction to the glide path. If the needle is up, the glide path is above the aircraft. If it is down, the glide path is below the aircraft. If it is centered in a horizontal position, the aircraft is directly on the glide path. The pilot should hold the attitude of the aircraft precisely when on the glide path and make path correction with power settings. Any appreciable change in power setting will result in a change in attitude unless the trim is also changed. Flap settings should not be changed when on the glide path. An increase in setting will balloon the aircraft above the path, and a decrease will cause the aircraft to sink below the path. Remember, the glide path needle should be kept within the limits of full scale fly down and half scale fly up. As the aircraft flies through the outer marker, the pilot carefully notes the time and cross-checks his altitude. After passing the outer marker, no heading corrections of over 5 degrees should be required, and they should be proportionately reduced in amount as the end of the runway is approached. The pilot should not become anxious if the vertical localizer needle oscillates momentarily. This is usually caused by a departing aircraft passing directly over the localizer transmitter on takeoff. This only lasts a second or two, and the needle then returns to its previous position. The pilot is kept busy holding the aircraft on the localizer heading and on the glide path. He cross-checks the ILS indicator with the gyro compass, the artificial horizon, and the other flight instruments. After passing over the middle marker, the corrections required to stay right on the localizer and glide path become even more precise. Meanwhile, the co-pilot keeps a close lookout for the first signs of visual contact with the ground or the approach and runway lights. The co-pilot tells the pilot when visual contact is made. Now the pilot looks away from the instrument panel and ahead to the approaching runway and levels the aircraft off for a normal landing. ILS provides the link between en route navigational aids and the touchdown point of the instrument runway and helps pilots to maintain safe, regular operation of their aircraft at all times.